In this video, we're going to talk about comparing objects. So I'm going to add a new class to this project, new Java class. We're going to call it point. Here we're going to declare two private fields, private int x and y. And now we want to generate a constructor for initializing these fields. So command and n, generate constructor. I'm going to select both these parameters and done. All right, let's go back to our main class. Here we're going to create 2 point objects. Let's call them point1 with these coordinates and point2 with the exact same coordinates. Now, if we print this expression, point1 equals point2, what do you think we're going to get? Let's take a look. We get false. Because both these points are reference types, so the values that are stored in these variables are the address of point objects in memory. Here we're dealing with 2 different point objects. That's why we have 2 different values inside these variables. Now, what if we use the equals method here? So point1 that equals point2. What do you think we're going to get? We're going to get the same result because the default implementation of this method in the object class compares 2 objects based on their references. Now, this is one of those situations where we want to override the equals method. We want to change its implementation to compare 2 point objects based on their coordinates. So back to our point class. After the constructor, we can manually override the equals method, but that is time consuming. Let me show you a shortcut. So once again, we're going to use command and n to bring up the generate palette. Now take a look. Here we can generate the equals method, but we don't want to do that yet. Instead, I'm going to select this command, override methods. So what do we want to override? These are the methods that the point class has inherited. So let's select the equals method. So IntelliJ automatically adds the override annotation as well as this method. Now in this implementation, we are calling the equals method in the super, which is our base class. We don't want this. We want to change it. So let's delete this line. Now look at the type of this parameter. It's object, and that means we can pass an instance of any classes that derives from the object class. But here we only want to deal with points. So here's the problem. If we change the parameter to point, we are not overriding the equals method in the object class. This is an entirely different method because it has a different signature. It has a different parameter. So we should revert this back to object and downcast this object to the point class. So point object, and we store the result in this variable. We can actually call it other. That's better. Now we can compare the coordinates of the current object and the other object. So return other.x equals x and other.y equals y. Now let's run our program and see what we get. We get true. That's exactly what we were looking for. However, our implementation has a problem. I told you that because the type of this parameter is object, we can literally pass any type of object to this method. So I can go back to the main method and compare this point with a text box. Now let's run our program and see what happens. We got an exception of type class cast exception. How can we solve this problem? Well, before casting, we need to make sure that this object that is passed here at runtime is an instance of the point class. So if object instance of point, then we want to execute these 2 statements. Otherwise, we're going to return false. Now, this implementation is a little bit ugly because we're indenting these lines. We can simplify this by reversing this condition. Let me show you. So we type if object is instance of point, but then we apply the not operator to this expression and then wrap it in another pair of parentheses. So if an object is not an instance of the point class, then we want to return false immediately. With this approach, we no longer have to add these curly braces and indent our code. So if we get to this point, that is obvious that this other object is an instance of the point class. So we cast it and then check the coordinates of these 2 point objects. Let's run our program and see what happens. Beautiful, our program didn't crash anymore. Now back to our main class. What if we compare an object with itself? So let's replace this text box with point 1. Our program still works, but here we can apply an optimization technique. So back to the point class. Instead of evaluating this expression, we can simply compare these two objects by their references. If they're referencing the same object, that means these 2 point objects are equal. So first of all, we want to make sure that these references are equal. So if this equals object, return true. So we're checking to see if the current object and this object that we receive here have the same reference or address in memory. So this is the proper way to override the equals method and compare objects based on their content. Now, as a best practice, whenever we override the equals method, we should also override the hashcode method. Let me show you. So once again, we're going to use our shortcut, Command and N, to override a method. This time, we're going to override the hashcode method. All right, this implementation is calling the hashcode method in the base class. We don't want this. Instead, we want to generate hashcode based on the content of this object, based on the values of the X and Y fields. How can we do that? Very easy. We have a class called objects. This is declared in Java.util package. Now, this class has a method for generating a hash value. So we can give it a bunch of values, and it will map these values to hash value. A hash, in theory, uniquely identifies objects. It's not 100% accurate, but it works for 99% of the time. Now look at the type of this parameter, that is object ... This means that we can pass a varying number of arguments to this method. We can give it 1 argument or 2 arguments or more. The Java compiler will pack these arguments into an array. So let's call the hash method and pass 2 values, X and Y. Now I'm going to return this new hash value. So let's see how this works. Back to our main class. These 2 objects are equal. We saw that. Now let's test our hashcode method. So we call the hashcode on point 1 and then on point 2. You can see that both these objects have the same hashcode, which is based on the content of these objects. In contrast, the default implementation of the hashcode method generates a hash based on the address of an object in memory. So if we go back to our point class and comment out this code, we're going to see 2 different hashes. Let's take a look. There you go. All right, now let me show you a cool trick. So here we overrode these 2 methods by hand, but we can have IntelliJ generate this entire code for us. Let me show you. So I'm going to select both these methods and comment them out. In case you're wondering, the shortcut is Command and slash on Mac or Control slash on Windows. All right, so we don't have this implementation anymore. Now we can have IntelliJ generate this for us. So let's bring up the generate palette and select equals and hashcode. Here we should select the template for generating the code. Leave it as is. Let's go to the next page. Now we need to select the fields that should be used for comparing these 2 objects. We want both these fields to be selected. So next. Similarly, we need to select the fields that should be used for calculating the hash. Once again, we want the combination of X and Y to generate a hash. Now finish. There you go. So here's our equals method. First, we're checking for reference equality. Then we have this expression, which is a bit different from what we wrote, but it has the same result. So we check to see if the other object is null. If it's not, we call the getClass method to return its class, and then we compare it with the class of the current object. If they have different classes, we return false. In our implementation, we use the instance of operator, and it has the same result. Now, otherwise, we downcast this object as a point and compare the coordinates of these 2 points. And here we have our hashcode method. The implementation is exactly like what we had before. So this is a very cool shortcut that you should have in your toolbox.